answer this interesting question. So it is saying a noisily grinding machine in a factory produces a sound intensity of 1.0 multiplied by 10 to the power negative 5 watts per meter squared. Okay, so the first question is saying calculate the decibel level of the machine. So we have the first one. Now, for us to answer this one, the first thing you need to know the formula. So the formula goes like this: the decibel of a given machine or decibel of the sound or sound decibel is equal to 10, then log, then open bracket intensity divided by the initial intensity. Usually the initial intensity is constant and it doesn't change. So this is the initial intensity and it doesn't change. So you just have to know this one here. Now, what are the units? So here you're going to find that the units are just the same, which are watts per meter squared. So these are the units for the constant intensity. So you have been taught to find this one here. So you can just say 10, then log. So in this question you have been given the sound intensity to be 1.0 multiplied by 10 to the power negative 5. So you can just replace that one. So this is what we have. So here, as you can see, the units are going to cancel each other. Okay. So when I do the computation here, what am I going to have? So I'm going to get 70.0. Then the units are decibels. So small letter D and capital B. So these are the units. That is for question A. Then for question B, it is saying the new intensity at when a second identical machine is added to the factory. So we have the first machine which was producing this intensity or sound intensity. Now again they have added another machine which is identical, so meaning that it is also going to produce the same intensity. So now that there are two, meaning you can just say 2 multiplied by the intensity which was produced by one machine. Then what are we going to get? So here we're going to get 2.0 multiplied by 10 to the power negative 5. Find the decibel. What are we going to do? We need to use this formula. So we can say 10, then log, open bracket. So here we have 2.0 multiplied by 10 to the power negative 5. Then divided by this one here, it is constant, it doesn't change. So we can say, then from there when I do the computation, I'm going to find that the decibel is going to be 73.0 decibels. So as you can see here, it has increased from 70 to 73. Okay, now let's try to answer the last question. It is saying a certain number of additional such machines are put into operation alongside these two machines. So when all of the machines are running at the same time, the decibel level is 77 decibel. Find the intensity. So here we are finding the intensity. We are not finding the decibel. We are finding this intensity. So you can just make the intensity the subject of the formula. So this is what we have. So this is what we have. Now we want to make this intensity the subject of the formula. So for this one, what do we have? We have the decibel, which is equal to 77.0 decibel. Then apart from that one, we have the initial sound intensity, which is 1.0 multiplied by 10 to the power negative 12 watts per meter squared. So we are finding the intensity. We don't know this one. We can write what we have. So we have 77 according to the formula, which is the decibel level, which is equal to 10, then log, open bracket intensity, divided by the initial intensity, which is just constant, it doesn't change. So we have 10, then log, open bracket intensity, divided by the initial intensity, which is 1.0, multiplied by 10 to the power negative 12 watts per meter squared. So this one is constant, doesn't change. So here I can just divide by 10, even here by 10, so that 10 and 10 they can cancel each other. So when I divide here, I'm going to get 7.7, which is equal to log, then open bracket, we have intensity divided by 1.0 multiplied by 10 to the power negative 12. So actually you're supposed to include the units. So this is what we have. Then from there, what are we going to do? You and I, we know to say that when you have been given log, this log here, it has a base 10 here. So to make sure that we express this one here in form of an exponential, this one has to go this side here, and this one here has to go this side, but it has to be a power of 10. So what are we going to have? This one is going to be the intensity divided by 1.0 multiplied by 10 to the power negative 12, then watts per meter squared. Then here we have 10, which is the base here, so it's going to be the power now. This 7.7 is going to be the power according to the law of exponential. And then from there, what are we going to do? Here I can just multiply throughout by 1.0 multiplied by 10 to the power negative 12 watts per meter squared, so that this one here and this one here can cancel each other. And then the intensity is going to be, when I multiply here, I'm going to get 5.01 multiplied by 10 to the power negative 5. Since it is intensity, it is going to be measured in watts per meters squared. So this is how you're supposed to answer this one. Thanks for watching.